Hello students, I'm Professor Sandeep Chaudhary and our topic for today is nothing but indexing mechanism. So to learn indexing, first of all we will have to learn about universal dividing head and the importance of indexing. Why do we need indexing basically? Why do we need indexing is the thing, suppose if we are having a circular plate, right? If we are having one circular disc, right? So that particular disk, if we want to divide into hexagonal bolt, or you can say a head of hexagonal bolt. So suppose the disk, I mean the rod is like this, and you need to divide it into six different parts, right? Like hexagonal parts. So that way, suppose if you want to create it, you need basically indexing. Another thing is, suppose you have been given one particular shaft, whether it is solid or hollow, and on the circumference you need to create holes of different sizes, or you can say of the same size, but the distance between the holes will be same. So that you can do it by means of indexing, or simply if you have been given a circular disc, and on the disc if you want to carve teeth, right? Or suppose simply you can say that you want to make a gear, spur gear or helical gear, whichever you want, but that you will be able to make with the help of indexing only. Manually, suppose if you want to make holes on the surface, and those holes specifically will be equispaced, if they are equispaced you cannot make it manually, right? So for that purpose you need indexing on this particular disk. Suppose if you want to create flat surfaces at equal distances, you cannot make it manually, so you will have to take help of indexing mechanism. So that particular indexing mechanism we will learn today. And suppose to learn indexing mechanism, we will have to first go through universal dividing head. That is the mechanism itself to understand universal indexing head. Now this is nothing but the universal indexing head, or you can say simple working principle of the indexing head. So you can see over here the plate over here is nothing but indexing plate. That particular indexing plate will be having equispaced hole carved on it, and it will be basically used for indexing mechanism, right? Over here you can see the indexing crank, which will be ultimately revolved around its axis, or you can say a worm shaft, and over here there is a spring loaded pin which will be ultimately connecting this particular indexing crank with the indexing plate. So according to the requirement of indexing mechanism, you will fix this particular spring loaded pin into the indexing plate, which will be ultimately helping in rotating the crank and indexing plate likewise, right? Now this is the driving gear. Over here there will be gears, bevel gears, which will be ultimately connected with each other, and ultimately the change of gear will be achieved by means of this particular worm gear and worm wheel, or you can say worm shaft. So as we all know that arrangement or combination of worm wheel and worm will be basically used for speed reduction. So over here what will happen is, like suppose if you are rotating this particular indexing crank, this particular worm wheel over here will be basically having 40 teeth. That is nothing but the standard. So that particular worm will be having 20 teeth inside, carved on the wheel, and ultimately what happens is this particular worm wheel will be ultimately connected with the spindle, and spindle will be connected with what? It will be connected with your workpiece, whatever it is, whether you want to go for six flat surfaces, or if you want to go for creating holes on the cylinder, or you can say you want to carve gear or cut teeth on a cylindrical disc, right? So that particular spindle will be connected with the work. So as you can say, as you rotate the crank, the worm shaft will be rotated, connected with it, and ultimately what will happen is this particular worm gear will be rotated, and nothing but worm wheel will be connected with spindle and ultimately workpiece. So workpiece will be rotated. Now what happens is, indexing a crank, if you rotate it, suppose once, or suppose there are 40 teeth, right? So if you rotate indexing crank 40 times, there will be single revolution of spindle, right? Or you, if you rotate indexing crank once, then 1 divided by 48th rotation of spindle will happen. That is the basic calculation. So suppose if you want to go for 20 holes, right, then what will happen, the if you rotate the indexing crank once, it will be rotating the spindle 1 by 48 times into multiplied by 1 divided by 28 of the holes. So 1 divided by 68 turn of one revolution will be rotated by means of spindle if you want to achieve that particular thing. Now if we see the indexing method types, there are different types, naming direct indexing, simple indexing, compound indexing and differential indexing. We will focus basically on direct and simple indexing, which are the most important methods usually will be asked for the exam. So direct indexing method can also be called as rapid indexing method, in that what will happen is direct indexing method and simple indexing method. So simple indexing method will be overcoming the disadvantage we achieve in the case of direct indexing method. So simple indexing method is when you want more complicated jobs to be created by means of indexing method, that we will see in the next lecture.